So students, in this first question, a ball rolls down from an inclined plane to a horizontal frictionless plane. So these are three figures, A, figure B and C. So this is figure C. So we are talking about this figure, that a ball rolls down from an inclined plane. So now the ball comes to the horizontal frictionless plane. So on this frictionless means there is no opposing force which is opposing this ball, and obviously so there is no forward, no backward force, so no force is acting on this ball. So the net force acting on it is 0. Okay. So tell me, out of these four options, which one is correct? The ball will stop after 10 seconds. The ball will continue to move with uniform acceleration. The ball will continue to move forever with uniform velocity. And will it start moving in a circular path? So which of the options are correct? Yes? Yes, Mayank? Tell me which of these options are correct? Nidhi?
Yes, sir.
Which of these options is correct? 1, 2, 3, 4?
Maybe option 1.
Option 1. Okay. Yes, Kanika?
Sir, I'm thinking.
Okay. Aditya? Vishesh? Pranshu?
Sir, option 2.
Option 2. Okay. So Pranshu, your answer is correct. That's option 2. Okay. But why option 2? If I say that your answer is correct, suppose. So then what's the reason that option 2 is the answer?
Because no force acting on the body.
Okay. So if there is no force acting on the body, the formula is force is equals to mass into acceleration. And there is no force acting on the body, so force acting on the body is 0. So 0 is equals to m into a. So what will be the value of a? Yes? A equals to 0. So if f equals to 0, then a equal to 0, because 0 equals to mass into 0, then only this side will be 0. So 0 equals to 0. So if force is 0, acceleration is 0. So which of the four options are correct?
Sir, option 2.
Option 2. Sir, option 2.
What about option 3? If acceleration is 0, what is acceleration? Acceleration is change in velocity divided by time taken. If that is your acceleration, so that is equals to 0. So what does this mean? Change in velocity upon time is 0. What does this mean? This means that change in velocity is equals to 0. Yes.
sir.
So change in velocity is equals to 0 means velocity is
0.
0.
there is no change in velocity. It means final velocity minus initial velocity equals to 0. So it means
Yes, sir.
final velocity is equals to the initial velocity. It means velocity is not changing. This is the meaning of acceleration equals to 0.
Yes, sir.
Acceleration equals to 0 means what? Velocity is not changing. So if the velocity is not changing, then what do you think? Which of these options is correct?
Sir, option number 2.
Option number 2. Okay. Yes, Nancy.
Yes, sir.
Which option is correct according to you?
Sir, option.
Okay. Pratham, which option is correct? Toshit,
Excuse me, sir.
yes,
Excuse me, sir.
yes.
3.
I think option 3.
Okay. Kanishka,
Yes, sir.
which option is correct?
Sir, option 3.
Option 3. Twinkle, yes. Yes, Kanika.
Sir, here acceleration and velocity both are 0, so they are same.
Where is written that velocity is 0?
The change in velocity is 0.
So what does this mean? If I'm telling you that the velocity is not changing, what does this mean? You are moving in a car and I'm telling you that the velocity is not changing. What does this mean? It means velocity is a vector quantity. So velocity has magnitude and its magnitude is known as speed, and velocity has direction also. If velocity is not changing, it means the speed of the car is not changing and the direction in which it is moving is also not changing. Yes.
Sir.
Then, so which option do you think is the correct one? 1, 2, 3, 4.
B.
Sir, option 3.
Yes, Piyush.
B.
Okay.
Sir, option 3.
Option 3. Okay. Yes, Aditya. Nancy.
Sorry, sir, by mistake.
Okay, which option do you think is correct? So all of you are agreed that the option 3 is the correct answer?
Yes, sir.
Yes, sir. Yes, sir. Yes, sir.
So that is what Newton's first law is. If there is no force acting on a body, then the state of the body will not be changed. That's Newton's first law.
Yes, sir.
So Newton's first law says that if F net is equals to 0, state of the body will not change. State means there will be two states. Either the body is moving with some velocity or it is at rest. So if it is at rest, then the velocity is 0, and if it is moving, it will have some velocity. So if F net is 0, then the state of body will not change. Why this will not change? Due to which property of the body this state will not change? Which property of the body? Yes. Which property of the body is not allowing the body to change its state if net force acting on it is 0? Which property of the body? We discussed it in the last class. Which property of the body is not allowing the body to change its state? What do we call that? Inertia of the body. Yes, very good, Nidhi. So inertia of the body does not allow the body to change its state. So it is the inertia of the body which is due to the mass. So more is the mass, more is the inertia. And this is Newton's second law. And how do we write Newton's second law in terms of momentum? Force is rate of change of momentum. What is, so Newton's law can be written as force is rate of change of momentum, and we can further derive the formula from it, that F is equals to ma. Okay, so these are Newton's second law. Okay,
Yes, sir.
so Newton's second law also says that if net force is zero, then acceleration is zero, and if acceleration is zero, it means the velocity is constant. So here, body moving with uniform acceleration is not correct, because acceleration is zero. हेलो, हाँ नमस्कार.
ये क्या है अभी सोमवार में आज ही कर लो
हाँ,
सोमवार में आज ही कर लो
सोमवार को मैं कल दिन में करूंगा बात में तुम्हारे से ना, कल दिन में फोन मिला के करना एक बार बात, ठीक है? So students, so here the acceleration is actually zero, so there is no uniform acceleration. Acceleration is actually zero, and in the third case, the body will continue to move forever with uniform velocity. So this is the actually so these were the three experiments that were performed by the Galileo. Means he observed that, like, you have a bowl, and if you put a ball over here and let this and just leave this ball, so the ball will come down and the ball will reach at the same vertical height from which you have left it. So same vertical height it will reach. Now again it will reach the same vertical height. Okay, now this ball, you have left this ball, and now the plane, it is horizontal plane, so the ball will not stop until it will find this same height. Okay, and as it is the plane surface, so the ball is not going to find this height, so it will keep on moving forever in search of this height. And as the surface is horizontal, the ball is not going to find this height, so that is why it will keep on moving forever. It stops on the ground because uneven force of friction, which is in the opposite direction, acts on it, and the ball decelerates and stop after some time. But here, this frictionless surface, so the ball will keep on moving until it reaches the vertical height from which it has started. So these are the observations, you can't say means observations of the motion of the ball by the Galileo. Okay, so on the double inclined plane, so this plane, this is inclined, this is another, so these are double inclined planes. And then he inferred that due to the law of inertia, it happens. Okay students, got this concept?
Yes, sir.
Okay, let us do the next question then. So that's the next question, that you are on ocean liner, that's a ship, and the ship which is sailing, and it is going eastward, so it is going in the east direction with the speed of 12 meters per second, and you run southward at 3.6 meter per second. So you are running southwards with a speed of, so you are on an ocean liner, so ocean liner is so big, so it's so big, this is ocean liner, So you are moving on the ocean liner itself at 3.6 meters per second. Okay.
Yes, sir.
So your speed is 3.6 meters per second, and the ocean liner, the speed is 12 meter per second in the east direction. So that's east, and this is south. So you are running southward. So you have to tell the magnitude and direction of your resulting velocity. So what will be the resulting velocity? Like the surface on which actually you are moving, that surface also moving. So your resulting velocity, if a person is, standing outside on the ground and he is watching you, so according to him, you will reach, due to this horizontal velocity, you will reach here horizontally, and due to this vertical velocity, you will reach here. So due to horizontal velocity, you will reach at point A if there will be only horizontal velocity, but there vertical also. So there will be two different motions, so horizontal and vertical. So two motions, and as a result, you will be moving in 1 second 12 meter horizontally, means 12 meter in the east direction and 3.6 meters in the south direction, right? Yes. So you will reach here. Yes. So
Yes, sir.
that's how we add the vectors. So you are adding these two velocities. This is v1, you can assume, and this is v2. So the resultant velocity is equals to velocity v1 plus velocity v2. And you know that to add the velocities, we use parallelogram law. So parallelogram law of vector addition, right? So this resultant velocity is actually your diagonal of parallelogram. So this diagonal of parallelogram is actually your, you were here, this was your initial position, this is your final position after 1 second, isn't it?
Yes, sir.
So what will be the length of this diagonal, students? This side is 3.6 meters. So 3.6 and 12. So how much will be this hypotenuse? So hypotenuse square is equals to perpendicular square plus base square. So that's equals to 12 square plus 3.6 square. So that's your hypotenuse square. So roughly how much you are going to get? So this is approximately 144. What is 3 square? Let us do it approximately. 3 square is
9.
4 square is 16.
16.
So what is 3.6 square? So 3.6 will be, what is the mid of 9 and 16? Mid is around means 13. Yes. So this 3.6 will be around 13. Yes. Yes or no?
Yes, sir.
So this is 12 square. What is 13 square, students?
169.
So definitely it is less than 169.
Yes, sir.
So,
Yes, sir.
so the answer will be less than 13.
Yes, sir.
So which of these answers is less than 13?
Option third. Option third.
Yes, option third. So these are, you can solve. And what is the direction? You can check the direction. Direction is also, which direction?
Southeast.
Southeast. So this is east direction, this is south direction. So this resultant, this diagonal is the direction of southeast. Agreed, students?
Yes, sir. Yes, sir.
Okay. So you should keep on noting down, keep on, You should make your notes. So you people are now very much comfortable with the parallelogram law of vector addition, yes? Okay. So have you noted it down? Shall we proceed further?
Yes, sir.
So the next question is, a machine gun fires n bullets per second, okay? And each of mass m. So if the speed of bullet is v, then the force of recoil is. So find out. So like this is the case. You have fired the bullet. This is your bullet. And you have fired your bullet in this direction. So the gun will recoil in this direction. That's the recoil force. Because here this gun is applying the force on the bullet, and bullet will, so that's Newton's third law, bullet will also apply force on the gun. And that is why gun will move in this direction. If bullet is moved in this direction, then the gun will recoil in this direction. So gun will move back in this direction. And here you have, I'm giving you the hint that here law of conservation of momentum. This concept is used. So very important law of conservation of momentum. Yes. So initial momentum means the initial momentum is equals to final momentum. Okay. So what was the initial momentum here? Initial momentum means the initial momentum of the gun plus bullet. What was the initial momentum of the gun? Before the bullet fired, what was the momentum of the gun? Zero, yes. Because why it was zero? Because momentum is equals to mass into velocity. So velocity is zero, so the momentum is zero. If anything is not moving, then the kinetic energy is zero and momentum is also. What was the initial momentum of the gun?
Zero.
It was also zero. Yes. So the net initial momentum was zero, because momentum of the gun plus momentum of the bullet, both their initial momentum was zero. And now let us talk about their final momentum. So their final momentum will be like final momentum of the gun. So mass of the gun into the velocity of the gun, final velocity of the gun, plus mass of bullet into the final velocity of the bullet. Their sum will be zero, because initial momentum is zero. So initial momentum is equal to final. So that's your final momentum. Initial momentum, that is equal to the initial momentum, which is 0. Okay. So this is 0. So this final momentum will also be 0. Okay.
Okay, sir.
Now what's your question? Your question is, if a machine gun fires n bullets per second, so So what and the speed of each bullet is v, then the force of recoil is, how much will be the force of the recoil? So tell me which of these option is correct. Option 2. Okay. So m is the mass of the bullet here, n is the number of bullet, and v is the speed of bullet. So all the three m and v are for the bullet. Yes. Yes, what about others?
Sir, option 2.
Option 2. So all of you agree that option 2 is correct? Anyone wants to say something? Option 2 is correct. Yes. Because the momentum of the bullet, so bullet is coming out with the velocity v, so its momentum will be m into v, and m into v, and as there are n bullets, so n will be multiplied to it. So mvn will be the momentum, and the recoil force of the gun is actually the accelerating force on the bullet. Okay. Let's do the next question. A man of weight W is standing on a lift. So that's a lift. And this is the man, and his weight is M over W. So this man has weight W. So students, do you know the difference between the mass and weight?
Yes, sir. Yes, sir.
Okay, tell me what is mass?
Figure of the energy in an object.
Yes.
Is the gravitational pull.
Okay.
Force with matter contain.
Okay, gravitational pull. That is weight. Okay, that is weight. What is mass?
Sir, mass is matter contained in an object.
Okay, good. So mass is the matter contained in the object. So mass is the matter, first thing, and weight is the force. That is gravitational force actually acting on the object. So that's the gravitational force, weight. So what will be, so definitely these are two different things. One is matter and another is force, gravitational force. So what are the units of mass? Unit of mass will be kilogram. And what will the unit of weight?
Newton.
Newton, yes.
Newton.
Yes, because it's the force, so its weight will be Newton. Third thing, mass will remain same on moon and earth, wherever you go, but the weight will be different. Why? Because this weight is this mass, the symbol is m. For the weight is equals to W, that is equals to m into g. Yes. And g depends on g, acceleration due to gravity depends on the how the earth is attracting us, that is, so that is W is equals to m into g. So g of earth and So this is the weight on Earth. Mass remains the same, but acceleration due to gravity will be lesser on the moon, almost 1/6 lesser. So if on the Earth it is 9.8, on the moon it will be, you can divide this value of g. Acceleration on the moon, acceleration due to gravity on the moon will be around 1.6 meter per second square. So as g will change, so weight will also be changed. So if you are dividing g by 6, so then weight will also be divided by 6. So weight will be different. It will be reduced by 1/6. Weight will be different on different heavenly bodies, on different planets or heavenly bodies. So moon is a satellite of, so different or different heavenly bodies. Okay, so that's the difference between mass and weight. Now here in this question it is weight. So this is the weight of the man. So, and he is standing on the lift, and lift is moving upward with acceleration A. So what is the apparent weight of the man? Yes, think about it, students. This is very important question. Yes. Let us see how many scenarios are possible. Yes. So apparent weight is not the real weight. Okay. Like some of the time you have a stone in your hand and you put your hand in the water. So does the does you feel the same weight of the stone when you put it in water? Yes. So the weight that you feel of the stone in water is actually the apparent weight. Okay, because there is upward force also acting on it. So that's not the real weight. Yes, students, got it?
Yes, sir. Yes, sir.
So if a lift is going up, so lift might go up, lift might go down, lift might fall freely. So these are the different options. So suppose first condition we'll see that the lift is at rest. Okay. So velocity is 0, acceleration is 0. See, this man is actually apparent weight of the man. So this is the weighing machine in the lift and the man is standing over here. So if there is gravitational force which is acting downwards, so if you are applying the force on the weighing machine, so the weighing machine will also apply force on you. There is spring balance in the machine, so it will also apply force on you, and that force is known as normal reaction, that is perpendicular to the surface. So that is Newton's third law. This man is applying a force on the weighing machine in the lift, and or even the surface of the lift you are standing. So the surface will also, like you are sitting on the chair, so you are applying the force on the chair, and the top layer molecules of the surface, you're pressing them actually. So that is why they are applying a force upwards. So you are applying force downwards, and a force, normal reaction force is applied by the chair, surface of the chair on you. That is why you are not moving, because net force is zero. The force you are applying on the surface, the gravitational pull, and the same force surface is applied on you. Got it, friends? So here, that is normal reaction. So upward force is normal reaction, downward force is mg. So lift is at rest, so that is why R is equals to mg. Okay, so apparent weight and actual weight remains the same. But what if the lift is moving upward? So if the lift is moving upward with the velocity v, and that is a constant velocity, so acceleration will be zero in this case. So as the velocity is constant, the downward force is the weight of the body, and the lift is moving upward. So suppose we are taking the upward action as positive, so the downward will be negative. So the net force, because net force acting is zero, because you are moving upward along with the lift with constant velocity. So if we are discussing the case of constant velocity, so acceleration is zero, so F net is zero. So what is the F net? Upward plus R, downward your weight, and net is zero. So it means R is equals to W. It means R is equals to mg. Okay. Now our case is, as we are doing, the lift is moving upward with acceleration A. So now see the net force acting on it. The force which is acting upward. See, the lift is accelerating upward with acceleration A. So it means F net is equals to m into A. Yes, students? Yes. Acceleration is due to the net force. What is the direction of acceleration? It's upward. So it means the net force is also upward. Yes. So what's your force in the upward direction? R. What is the force in the downward direction? Mg. So which one is greater? Tell me. R or mg? Which one is greater? Tell me. See, you are moving upward with acceleration A. It means net force is acting in the upward direction, because force and acceleration will be in the same direction. So it means F net is upward direction. So tell me, what is F net? Which one is greater? R greater or mg is greater? Mg is the, yes, which one is greater?
R. Sir, R.
R is greater. So because upward force is greater, that is why it is moving in upward, as acceleration is in upward direction. So the net force means R minus mg is equals to ma. Okay. So you whether you write here mg or you write w, that is the same thing. Yes or no?
Yes, sir.
So R minus W is equals to MA. Yes?
Yes, sir. Yes, sir.
So, or if you take mg or R, so if you want to find R, so that will be equals to, this mg will come this side, so ma plus mg. and this MA is common, so A plus G. So that will be the reaction force, and that will be actually your apparent weight. This is the apparent weight which will be shown by the weighing machine in the lift if the lift is moving in the upward direction. So your weight will be shown more or less when the lift is moving upward with so the apparent weight will be more or less than the real weight. See, your real weight is what? Mg, but here you are adding m into a. Yes. So net, so it will be showing the greater weight in the machine. Okay. So the machine shown is m into a plus g. Suppose your weight is student switch. Take care of your mic. Okay. So suppose your weight is 60. So mass is 10. Okay, let it be means mass is suppose 6 kg. And acceleration due to gravity, let us take it approximately 10. So your weight is 60 Newton. But if the lift is moving in upward direction with 1 meter per second square, students, then what will be your mass? Oh, sorry. What will be your apparent weight showing on the machine? That will be 6 into acceleration is 1 meter per second square. Okay. So what will be their weight? 1 plus 10. So what it comes out to be? 6 into 11, that is 66 Newton. So this will be the weight, your apparent weight. So your apparent weight increases by 6 Newton. Suppose if this lift is moving upward with acceleration 2 meter per second square. So then students, what will be your apparent weight? If A is equals to 2 meter per second square, lift is moving up with 2 meter per second square.
72.
Yes. So the weighing machine will show your weight 72. Okay. 72 Newton. Yes. So your apparent weight will be 72 Newton because A is equals to. So now you have understood, you just write down this formula. Okay. And how have you got this formula? You know it. Okay. But the formula is apparent weight is equals to m into A minus G. Suppose now if the lift is moving downward, okay, then the upward forces are, downward force is your weight mg. Which force is greater? Because F net is equals to m into A. So here the acceleration is downwards, A is downward, okay. So tell me, so acceleration is downward direction, so F net will also be in downward direction, students. Yes or no?
Yes, sir.
Both are supposed to be in the same direction. Both are vectors. Mass is scalar. So both are in the same direction. So tell me which one will be greater? Your weight or R?
Wait.
Weight. So that is why weight is greater. So that is why this time we will subtract W minus R. That is equals to M into A. And W is your mg. So mg minus R is equals to ma. So R will go that side and ma will come this side. So mg minus ma is equals to R. And m you can take common. So you get R is equals to m into g minus a. Is this clear, students?
Yes, sir. Yes, sir. Yes, sir.
So you have got two formulas. If the lift is moving upward with acceleration A, then the apparent weight will be, what will the apparent weight? M into A plus G. And if the lift is moving downward with acceleration A, then your apparent weight will be M into G minus A. Is this clear?
Yes, sir.
So now tell me, if the lift is moving downward, if there is free fall, what is it?
Free fall.
Free fall means the lift is, is disconnected somehow and it is falling down. It's a free fall. So it will fall down with G, acceleration due to gravity. So the acceleration will be equals to G during the free fall. Yes or no?
Yes,
Yes,
sir.
sir.
So then what will be the weight that you will feel in the lift, miss? If the lift is falling down with acceleration due to gravity G. So put A equals to G here, students. What will be the value of R equals to? Your apparent weight equals to M into G minus, this A also equals to G because the lift is falling freely. So G minus G, that is equals to 0. So M into 0 is 0. So that is weightlessness. What do we call it?
Weightlessness.
Yes.
So you will feel that you are weightless. In the machine, the pointer will comes to 0. Okay, because the lift is falling down with gravitational acceleration due to gravity G. So the apparent weight is equals to M into G minus A, and A is equals to G. So that is weightlessness. If the lift, if somehow that rod or the wire which is damaged and lift is falling freely. I hope you have understood these concepts, friends.
Yes, sir.
Yes, sir.
So note down these two important formulas. R is equals to G plus A if the lift is moving upward with acceleration A, and apparent weight is equals to M into G minus A if the lift is moving downward with acceleration A. Okay. Now let us come back. We have understood this concept well. Now let us come back to our question. So the question is, a man of weight W is standing on a lift. Okay. So he is standing on a lift which is moving upward with acceleration A, right? So the apparent weight of the man. So you know that the apparent weight of the man, that is the reaction, will be equals to M into G plus A. Yes.
Yes, sir.
Sir.
So apparent weight is equals to M into G plus A, or you can write it as R equals to mg plus ma, isn't it?
Yes, sir.
So which of these options is correct? This apparent
Option
weight.
Option A.
Option A. So what is option A? If we simplify it, this W is equals to M into G. So M into G into 1 plus A by G. So when you multiply mg here, so you will get mg, right? And even when you multiply mg into A, G cancels out and you get M into A. Is this clear, students?
Yes, sir.
And if the lift was falling down, if I change this question, the lift is moving downward instead of upward. If I write the word here downward, then which option will be correct?
Option 3.
Yes, very good. Then option 3 will be correct, because put here mg and you will so you will get mg minus this or you can just multiply g inside, right? So you will get g here. So g minus g cancel, g minus, so mg minus. So if the lift is moving upward with acceleration A, then this is correct. If the lift is moving downward with acceleration A, then this option is correct. And when do we have this option, students? But when do we have this option? Second.
The lift is in free fall.
No. When the lift is in free fall, then the option 5 will be 0. Free fall means apparent weight will be 0.
0.
Yes, why? Because apparent weight will be equals to m into g minus a, and a is also g, so that is 0. So that is for the free fall. When do we get this option? Yes, this is the first case that we discussed.
Sir, when lift is at rest.
Very good. When the lift is at rest. So when the lift is at rest, your a is 0, so cancel this a. So your apparent weight is equals to real weight. It isn't it?
Yes, sir.
Agreed, students?
Yes, sir.
Yes, sir.
So very important discussions regarding the lift we did. You can even watch the video again if there is some confusion. Otherwise, I hope that you people have understood this concept very well, and this very important concept. You are going to find these questions means in your higher classes also. Okay, even in your JSTSC and TSC, and in your higher classes when you will study physics. So just note it down if you have not noted it down. Do you have any questions regarding this? Anything you have not understood regarding this concept, lift? You can ask. Yes? Shall we do another question then? Yes?
Yes,
Yes,
sir.
sir.
Have you noted it down, students? Please note this question down. And all these options, like when do we get option 1, when do you get option 2 when the lift is at rest, when do you get option 3, and when do you get option 5. You are not going to get option 4. Okay?
Yes, sir.
Yes, sir.
So we are not doing any particular question, but we are learning the whole concept. So written it down.
Yes, sir.
Take your own time and write it down. That's very important. If you have any questions, you can ask. Very, very important concept. Everybody has noted it down. Shall we move forward? Yes, shall we move forward?
Yes, sir.
Okay. Okay, students. So let us do the next question. So now we'll do question of graph. We haven't done any question of graph today. So we have to tell what this graph is telling us. Okay. So we have displacement time graph. Which situation it is telling? This is time. This is displacement. And you have this graph. So what information this graph is giving you? Yes. What is the information this graph is giving you? Displacement time graph. What does this telling you?
Sir, the slope of displacement time graph yield velocity.
Yes, very good. Very good. So the slope, slope is change in y-axis upon change in x-axis. So change in y-axis is your displacement. So that's your, you will find the units in meter, and change on x-axis you will find the units in seconds. So meter per second is the Velocity, yes, absolutely right. So the slope gives you the velocity of displacement time graph. So what is the slope here in this case? Slope is equals to 0 because it's horizontal line. Yes, because 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 x-axis is changing, but change in y-axis is 0. So if you have 0 over here, because on the y-axis if it is 10 meter, it's 10 10 10, so there's no change on y-axis, so y-axis change is 0, so 0 upon anything is 0. And another thing is that in terms of angle also I told you that slope is equals to tan theta, remember? Yes.
Yes, sir.
So here the angle that it is making with the x-axis is 0 because it is parallel to x-axis. So here tan 0 and tan 0 is equals to 0. So the slope is 0. It means the velocity is 0. So slope is 0. So right slope or right velocity, that is the same thing. So velocity is 0. So there is no change in velocity. So velocity is 0 means velocity is not change, means the object is at rest.
Yes.
Yes or no?
Yes, sir.
So object is at rest. Okay. Next graph. Suppose you have graph like this. Okay. Same displacement time graph. This is in second, this is in meters. So students, first thing let us discuss about the slope. So what is happening with the slope? This is the slope at this point. This is the slope at this point, tangent. This is the slope at this point. This is the slope at this point. Okay. So what is it telling you the slope? See the angle theta. What is happening to the theta? What is happening to the slope? If you slide over here, and if you slide over here, where you will find the slope? More. Is the slope increasing or decreasing? Yes. Slope is increasing. Right. Is the slope positive or negative?
Positive.
Yes, slope is positive. If you ride a bicycle, suppose from here, so bicycle is going up. So slope is positive. So slope is positive, slope is increasing. What is the slope of displacement type graph? Slope is nothing but velocity. So whether you write the word slope or you write the word velocity, that is the same thing, right? So it means the velocity is increasing. Can you give me some example when the velocity is increasing? Natural example. When the velocity is increasing means there is acceleration taking place. Yes. Yes. What happens when a ball is falling down? So will the velocity increase or doesn't increase?
Increase.
Yes. Velocity increases. Right. So, and this displacement. So S is equals to ut plus half at square. So you see here the S has power 1 and t has power 2, exponent 2. So obviously you are not going to get a straight line, but you are going to get this parabola, isn't it? Because it's t square. Yes. So when the ball is falling down, you get this graph with the displacement. Got it, students? Remember, we did one question also, that the distance traveled in the successive intervals of time. What we were getting? 1 in the first interval 1, and then 3:5:7. Remember? We did this question yesterday.
Yes, sir.
In the first interval of time, in the second interval of time, in the third interval of time, in the fourth interval of time. Remember? Yes.
Yes, sir.
So for the same time, more distance. So this is time suppose 1 second, this is time suppose 2 seconds, this is a time suppose. So this is 1 second, this is 2 second, and this is so see how much is the distance traveled in 1 second, this much. How much is the distance traveled in 2 second, this much. So this is, if this is 1, this is 3 times more than that, isn't it? Because the net distance will be 2 square. 2 square is 4. Now the net distance for the 3 seconds will be, remember, 3 square, it will be 9. Yes, ball is dropped, u is equals to 0. Remember, putting
Yes.
t is equals to tau, then 2 tau, then 3 tau. So it will be 3, 3 the 9. So if this is 4, so how much the distance traveled? This will be 5. So the distance traveled will be in the ratio 1 is to 3 is to 5. Remember, students? So this is the distance.
Yes, sir.
In the successive time interval, this time can be 1 second, this time can be half second, this time can be 2 seconds, this time can be 5 seconds, this time can be 1 minute also. So in the successive time interval, the distance traveled will be 1 is to 3 is to 5 is to 7. So you get this graph. So students, it's very important to remember this graph. Now let us discuss the next graph of the displacement time. You can see here that the theta is increasing, and the value of tan theta is directly proportional to theta. Okay, so if the the slope is nothing but tan theta, so more is the theta, more will be the slope. Okay, up to 90 degree. Yes, I'm
Yes,
talking.
sir.
I'm talking about this theta is between 0 and 90. Okay, when this theta, when this will be like right angle, so starting from here the slope is increasing, and see here the slope is infinity at 90 degree 10, and after this, if this is the angle, then this will be the obtuse angle, isn't it? And for the obtuse angle, if you ride a bicycle from left to right, the bicycle will come down. If you ride a bicycle from left to right, here the bicycle is going up. So that's negative slope. So up to 90 degree acute angle, your slope is positive, and when the angle is obtuse, up to 180 degree, you will get negative slope, right?
Yes, sir.
Yes, sir.
So that's this angle. If this is the line, what is the slope? So slope, how much is it, the angle it is making with the x-axis? So you have to make that angle always in the clockwise direction. So remember this thing, in the clockwise direction make this angle, and this theta is obtuse, so this slope, and even if you ride a bicycle from left to right, so you will come down, so this slope is negative, and theta is also obtuse. Okay, students, so you are learning the concept of slope also simultaneously. Now we have the next question, or means the next graph, displacement time graph, and this time this is the graph, students. So when do we get this graph? What about the slope? The slope that we are discussing. Tell me about the slope. What do you tell about the slope? Yes, what do you say about the slope? Is the slope constant or is the slope changing? See, is the angle theta changing?
No,
No,
sir.
sir.
Then
Sir.
it's a straight line. It's a straight line. Theta is not changing. So slope is also not changing, because slope is equals to tan theta. And if theta is not changing, slope is same. Yes, it's a straight line. So the slope is a constant. So what can we write instead of slope? What is the slope here? Displacement time graph.
Velocity.
So velocity is constant. So if velocity is constant, what kind of motion is it? Very good, very good. Velocity is constant, it's uniform motion. So that is the graph of uniform motion. Yes, students. So in uniform motion, how much is the acceleration? Acceleration equals to, what is acceleration? Acceleration is changing velocity. Velocity is not changing. Velocity is constant. How much will be the acceleration? Zero. So how much is the net force acting on the object?
Zero.
Zero. Very good. Okay. So that's again Newton's first law. If the net force acting on the object, then the state of the object will not change. And if the object is moving, then there will be uniform motion. Velocity will be constant. Agreed?
Yes, sir.
Yes, sir.
Very good. Now let us make another graph of displacement time graph. So this sort of revision we are doing, isn't it? We have done these things earlier. Yes. Tell
Yes,
me.
sir.
When do we get this graph, students? These are all displacement time graph. So what is happening with the slope? Very important thing. Let us see what is happening with the slope, students. Here this is the slope. What is happening with the slope? Tell me. Here the slope is increasing or decreasing? Yes. See the angle theta. Yes, very good. First, here the slope is increasing or decreasing? A, B, C. Yes, here. Up to from point 0 to A. Yes, 0 to A. Slope, देखो ये है ना आपका स्लोप, ये एंगल थीटा. थीटा इंक्रीज हो रहा है या डिक्रीज हो रहा है?
Decrease.
So slope is decreasing from O to A. Agreed or not agreed? So what can you write instead of slope word? What is the slope? Velocity. So velocity is decreasing, right? And then here what is the slope at point A? At A. Yes.
Zero.
Slope is 0. So it means velocity is 0.
Yes.
Means the object is at rest. Then from A to B, what is the slope?
Sir, increasing.
Slope is increasing. Very good. Yes.
Velocity is increasing.
Yes, the slope is increasing. You can see that this lesser slope and this more slope, this more slope. So slope is increasing. So velocity is increasing. Yes or no?
Yes,
Yes,
sir.
sir.
Yes, sir.
So velocity is decreasing first, then the velocity is 0, and then the velocity is increasing. When does this happens? When does this happen? When you throw a ball upward, what happens? Does the velocity decrease?
Yes, sir.
And what happens when the ball comes at the maximum height?
Zero.
And what happens when the ball again comes down?
Sir, velocity increase.
Yes, velocity increase. So what is the displacement when the ball was initially started? Displacement and it comes back to the same point. What is the displacement?
Sir, zero.
0.
Sir, zero.
Yes, and what is the displacement when the ball was at rest? What is the displacement at that time? It was a maximum, isn't it?
Yes, sir.
So displacement was maximum when the ball was at rest momentarily. Yes. Got this, students? Got this point?
Yes, sir.
Yes, sir.
And next thing you can see, what is the slope positive or negative from 0 to A? Is the slope positive or negative? This is the slope. Is it positive or negative?
Positive. Sir, positive.
Yes, positive slope. What is the slope here? This angle?
Negative.
Negative.
Sir, negative.
So slope is negative. So this negative positive tells you the direction. What does this tell you?
Direction.
So you have taken the upward direction, which is the initial direction of motion, as positive. So that is why velocity is decreasing,
Decreasing.
but it was in positive direction, means in the upward direction. Yes. And here from A to B, slope is negative. Negative means direction. Again, the velocity, what is the direction of velocity? Negative, because downward direction will be negative. So if upward is positive, downward direction will be negative. So students, these are two different things. So if the slope is positive, it is telling you the direction. If the slope is negative, it is telling you the direction. But the magnitude of the slope tells you the magnitude of the velocity. So velocity is a vector quantity and it has two things, magnitude as well as direction. Is this okay?
Yes, sir. Yes, sir.
So velocity is a vector quantity so it has two things, magnitude as well as a direction. So magnitude will be given to you by tan theta, that is the magnitude. Yes.
Yes, sir.
And this direction is actually will be given to you by the sign, whether the slope is positive or negative. So here means you are finding only the magnitude, so only the absolute value of the slope means it will always be, the magnitude are always positive. So the magnitude gives you so here this slope, the absolute value of the slope will tell you the magnitude, and whether the slope is positive or negative will tell you the direction of the velocity.
Direction.
So I hope students that this concept is pretty much clear. Yes,
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 sir.
sir. Yes, sir.
that's good. So now let us do some questions of velocity time graph, which will just tell you whether it is a direction in one dimension. Is it a one dimension motion? Means direction in a straight line. You have to tell whether the motion is one dimensional. Okay. One dimensional means along a straight line, along a
Straight line.
yes. So you have to tell me. Okay, that's your question. I am giving you graphs. First graph. This velocity time graph now this time, students, and that's your graph. So you have to tell me that is it a one dimensional. I'm giving you four options. Okay, one of this graph is only in one graph it's one dimensional. Third graph, all are velocity time graph. Okay, this is the fourth graph. Tell me which of these graph tells you one dimensional motion. 1, 2, 3, 4. Yes. Come on.
Option 1.
Option 1. Okay. Yes. What others think?
Sir, option 1.
Mm-hmm.
Option 1.
Okay. See, there can be one correct answer, there can be two correct answer, there can be three correct answer in this question, students. So which one of the motion is one dimensional? Okay, one is one dimensional. Which other motion is one dimensional? Is the two one dimensional motion? See what happens in this graph. See what happens. So is this a realistic situation? This graph. See, is it possible that at this particular time, suppose this is 2 second, at the time 2 second, can a object has two velocities? Is it possible?
No, sir.
No, sir.
Huh? Can is it possible that it has the velocity 3 meter per second and it has the velocity 10 meter per second at the same time? Is it possible?
No, sir.
No, sir.
No. So this is not a realistic graph. And rest of the graphs are, yes, that's realistic. One velocity at a time. That's also okay. So these are all graphs of one-dimensional motion. But this graph is not possible. Okay.
Yes, sir. Okay, sir.
So students, that's all for today. Thank you so much for being with me. And tomorrow also there will be a class. I will send you the message. If there will be a class, there will be class at in the morning and in the evening also, same time. I will send you the message. So thank you for being with me.
Thank you, sir.
Thank you, sir. Thank you, sir. Good evening, sir.